If you multiply AB and transpose it, AB whole dash is always equal to B dash into A dash, that is called as the reversal law of transpose. Now third row, first column, second column, third column, minus 4 2s are 8, minus into minus plus, minus 4 4s are 16, minus 5 4s are 20. This is equation number 2. If A dash is equal to A, then it is called a symmetric matrix. If A dash is equal to minus A, then it is called a skew symmetric matrix. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today in this session, I am going to discuss regarding very important concept, that is regarding the transpose of a matrix and the problems based on transpose as well as a symmetric and a skew symmetric matrices. Now, let us come to the first one, is the transpose of a matrix. Now, what is a transpose? Transpose is nothing but interchanging the rows to column and columns to rows. Changing rows to column and columns to rows is called as the transpose. And the transpose of a matrix is denoted as A dash or AC. AC is called a complement. Now, let us explain in detail. If A is a matrix obtained by interchanging the rows and columns is called the transpose of a matrix. So, a matrix obtained by interchanging the rows and columns is called the transpose of a matrix, and it is denoted as A dash or AT. A dash or AT is called the transpose of a matrix. So, a matrix obtained by interchanging the rows to column and columns to rows is called the transpose. And if A is a matrix, then the transpose of this is denoted as A dash, or it is also denoted as AT, is called the transpose. Now, if A is a matrix of order m cross n, then its transpose A dash is of order n into m. So, if A is a matrix of order m cross n, then its transpose A dash is of order n cross m. So, for example, if A is a matrix of order 3 into 2, then the transpose of this is A dash is of order 2 cross 3. So, this is how we are going to represent the transpose of a matrix. Now, let us take for example, if A is equal to 1, 2, 3, 3 minus 2 and minus 1, then the transpose of this is A dash is equal to, just write down the first row as first column. First row becomes first column 1, 2, 3, and the second row becomes second column 3 minus 2 and minus 1. See, first row is first column here and the second row is second column here. That is, the rows are transposed into the column. This is called the transpose, denoted as A dash. Now, what is the order? This is of order 2 rows and 3 column. 2 rows, 3 column. Whereas this is of order first row, second row, third row, 3 rows and 2 columns. So, if A is a matrix of order 2 into 3, then its transpose is of order 3 cross 2. Now, let me take one more example. If A is equal to a matrix 1, 2 and 3, then the transpose of this is denoted as AT or A dash. The transpose of this is A dash is equal to, what is this? So, first row, this is only one column is there, first row, second row, third row, this can be written as 1, 2 and 3. So, what is the order? 1, 2, 3, this is of order 3 rows, 1 column, this is of order 1 into 3. That means, this is a column matrix. Whenever it is changed to, then it will becomes the row matrix. The column matrix will transpose us to the row matrix. Let me take one more example. If B is equal to 2, 4, 5, 6, then the transpose of this is denoted as B dash is equal to, first row become first column 2, 4, and the second row can be written as second column 5, 5 and 6. The order is same, 2 rows, 2 column, 2 rows, 2 column. So, a matrix obtained by interchanging the rows into columns and columns into rows is called as the transpose of a matrix, and it is denoted as A dash or AT. Now, let us come to the very important properties. The transpose of a transposed matrix is always equal to A. If you transpose a matrix 2 times, you will get the same matrix. The transpose of a transposed matrix is always equal to the same matrix. And A plus B whole dash, if you transpose A plus B, the transpose of A plus B is equal to A dash plus B dash. A plus B whole dash is equal to A dash plus B dash. And suppose if K is any constant, then K into A dash is equal to constant. If you multiply a matrix with a constant and transpose it, or transpose a matrix and multiply by a constant k. So k into a whole dash is also equal to k into a dash, where k is a constant. Now let us take an example, and one more property, that is ab whole dash is equal to b dash a dash. This is called the reversal law of transpose. If you multiply ab and transpose it, ab whole dash is always equal to b dash into a dash. That is called as the reversal law of transpose. Whereas if you add or subtract a plus or minus b whole dash is always equal to a dash plus or minus b dash. If it is plus a dash plus b dash, if it is minus a dash minus b dash. Now let us take an example. If a is equal to 1, 2, 3, 4, then prove that a dash whole dash is equal to the same matrix. What is given? A is equal to 1, 2, 3, 4. Transpose this. A dash is equal to, the transpose of this is first row becomes first column 1, 2, and second row becomes second column 3, 4. So this is of order 2 into 2. Now again transpose this. Again transpose of a transposed matrix. A dash whole dash. So transpose of this, first row becomes first column, that is 1, 3, and this becomes 2, 4. So what is this equal to? 1, 2, 3, 4. This is equal to the same matrix, given matrix A. That means A dash whole dash. The transpose of a transposed matrix is always equal to the same matrix. A dash whole dash is always equal to A. Okay. Now let us take a very important problem for 5 marks. You may expect this type of questions for 5 marks. Very important problems for the point of examination. These type of problems are very important. Now if A is equal to 3, 3, 2, 4, 2, 0, B is equal to 2, minus 1, 2, 1, 2 and 4, then verify that A plus B whole dash is equal to A dash plus B dash. Now let us find out first one. On the left hand side, what we have? LHS A plus B whole dash. First find out A plus B and transpose it. On the right hand side, we have A dash plus B dash. Find out A dash and B dash. Add LHS and RHS are found to be same. Now let us take the first LHS A plus B. A plus B. Write down A plus B. What is A? 3, 3, 2 and 4, 2, 0 plus B. 2, minus 1, 2 and 1, 2, 4. Let us add these two. If you add, what you will get? 3 plus 2 is 5. 3 minus 1. 3 minus 1 is 2. 2 plus 2 is equal to 4. 4 plus 1 is 5. 2 plus 2 is 4. 0 plus 4 is equal to 4. Now LHS. What we have in the LHS? LHS is A plus B whole dash. Transpose this. The transpose of this is first row 5, 2, 4. First row becomes first column 5, 2, 4. And the second row, what is second row? 5, 4, 4. Second row becomes second column 5, 4 and 4. Let us represent this as equation number 1. Okay, see here, just find out A plus B. What is A plus B? Write down the elements of A and B. A contains 3, 3, 2 in the first row, second row 4, 2, 0 plus B contains 2, minus 1, 2 and 1, 2, 4. Corresponding elements must be added. That is addition of matrices. 3 plus 2 is 5, 3 minus 1 is 2, 2 plus 2 is 4, 4 plus 1 is 5, 2 plus 2 is 4, 0 plus 4 is 0. Now, what is LHS? We have A plus B whole dash. Transpose this. Transpose of this. First row 5, 2, 4 becomes first column and the second row 5, 4, 4 becomes second column. On the right hand side, so let us come to the second part. So find out A dash and B dash. The transpose of A. The transpose of A is 3, 3, 3. First row can be written as first column 3, 3, 2 and second row 4, 2, 0. This is A dash. On the other hand, what is B dash? So second, this B dash is transpose of B, 2, minus 1 and 2 and the second row becomes second column 1, 2 and 4. Now let us add these two. RHS. What is RHS? A dash plus B dash. A dash. What is A dash? 3, 3, 2, 4, 2, 0 plus 2, 1, minus 1, 2 and 2, 4. Add this. If you add, what you will get? 3 plus 2 is 5. 4 plus 1 is 5. Again 3 minus 1 is 2. Again 2 plus 2 is 4. 2 plus 2 is 4. 0 plus 4 is 4. This is equation number 2. See, what do you say from equation number 1 and 2? Equation 1 contains in the first row 5 and 5. Equation 2 also contains first row 5 and 5. Second row 2, 4, 2, 4, 4. So from 1 and 2, LHS is equal to RHS. So from 1 and 2, we can say that from 1 and 2, LHS is equal to RHS. LHS is equal to RHS. That means A plus B whole dash is equal to A dash plus B dash. Very important. If you do this much, definitely you will get 5 marks. Okay. A plus B whole dash is equal to A dash plus B dash. Similarly, you can verify. Similarly, you can prove A minus B whole dash is equal to A dash minus B dash. If you want, you can verify A minus B whole dash is also equal to A dash minus B dash. For that, subtract A and B, A minus B and transpose it, and A dash minus B dash. Subtract A dash and B dash, you will get the same answer. That is LHS and RHS are found to be same. So you can conclude A minus B whole dash is also equal to A dash minus B dash. So you may expect either this or that. A plus B whole dash is equal to A dash plus B dash, or A minus B whole dash is equal to A dash minus B dash for 5 marks. Now, let us come to the next problem. Now, this is also a very important problem for 5 marks. This is also a 5-marker question. Now, what is this reversal law of transpose? That is, what is to prove AB whole dash is equal to A dash and B dash. What is A given? A minus 2, 4 and 5 first row, and B contains first column, 1, 2 and minus 4. What is to prove AB whole dash is equal to B dash and A dash? Very important. While solving this type of problem, one should be familiar with the order. First, write down the order and check whether it is possible to multiply it or not. So, once if it is possible to multiply, definitely you can get the answer in a very easiest method. Now, let us write down the LHS. AB, first write down AB. What is A? A is minus 2, 4 and 5. And B, what is B contain? B contains 1, 2, minus 4. Check whether it is possible to multiply it or not. What is the order of A? A contains 1, 2, 3 row, 1 column. B contains 1 row and 3 columns. Since these two elements are same or equal, so we can multiply, and the matrix we are going to get is of order 3 rows, 3 column. So that is equal to 3 rows, 3 column matrix you are going to get. Put the order first and don't get confused. So this is first row, first column, second column, third column. Minus 1 into 2 is minus 2. Again same row, second column, minus 2 into 2 is minus 4. Again minus into minus plus, 2 4s are 8. First row, first column, second column, third column. Similarly, come to the second row. Second row contains only one element. Second row, first column, second column, third column. First column, second column, third column. 4 1s are 4. Again 4 2s are 8. 4 4s are 16 along with negative sign, minus 16. Now, come to the third row. Third row, first column, second column, third row. Third row, first column, second column, third column. 5 1s are 5. 5 2s are 10. 5 4s are 20, minus 20. This is AB. Now, transpose this. Now, therefore, AB whole dash is equal to, the transpose of this is minus 2, minus 4, 8. First row becomes first column. Second row, 4, 8, minus 16 converts to second column. And the third row becomes third column, 5, 10 and minus 20. This is equation number 1. Right. Very simple. See, first row, first column, second column, third column. Second row, first column, second column, third column. Third row, first column, second column, third column. So there is no need of addition or subtraction anything. So this is of order 3 rows and 3 columns. On the other hand, find out B dash and A dash. Now B dash and A dash. This is LHS. This is LHS. And come to the RHS. RHS is nothing but B dash, A dash. What is the transpose of B? B is 1, 2, minus 4 into transpose of A, minus 2, 4 and 5. So, minus 2, 4 and 5. So, this first row becomes, row matrix becomes column matrix, and column matrix becomes row matrix in this case. Now, similar, first row, first column, second column, third column. What is that equal to? Check, this is also of order. What is the order? 1, 2, 3 rows, 1 column. This is 1 row, 3 column. Since these two elements are same, and you are going to get a matrix of order 3 rows, 3 column. Since the orders are same, we are going to get a matrix of order. Now let us multiply this. So since these two are equal, so we are going to get a matrix of order 3 rows and 3 column. First row, first column, second column, third column. 1 into minus 2 is minus 2. 1 into 4 is 4. 1 into 5 is 5. Similarly, second row, first column, second column, and third column. So 2 2s are 4, minus 4. 2 4s are 8. Again 2 5s are 10. Now third row, first column, second column, third column, minus 4 2s are 8, minus into minus plus, minus 4 4s are 16, minus 5 4s are 20. This is equation number 2. This is nothing but the transpose of B dash and A dash. See what is equation 1 and 2. So equation 1 contains minus 4, minus 2, 4 and 5 in the first row. Equation 2 also contains minus 2, 4 and 5 in the first row. Second row, minus 4, 8, 10, minus 4, 8, 10. Third row, 8, minus 16, minus 20. So what is say from 1 and 2? LHS is equal to RHS. So from 1 and 2, therefore, from 1 and 2, LHS is equal to RHS. LHS is equal to RHS. So therefore, AB whole dash is equal to B dash into A dash. So that is called, this is called the reversal law of transpose. AB whole dash is equal to B dash A dash. Very, very important type problem for 5 marks. So very easy, and don't get confused while solving this type of problems. Okay. Now hope you followed. Now the next one is very important, symmetric matrix. So symmetric matrix. Symmetric matrix means if A dash is equal to A, the matrix and the transpose are same. Such a matrix is called the symmetric matrix. Symmetric with respect to the principal diagonal. So a matrix, square matrix A is equal to Aij is said to be a symmetric matrix if A dash is equal to A. If the transpose of the matrix and the matrix are same, then it is called the symmetric matrix. That means if all the elements above the principal diagonal must be equal to elements below the principal diagonal, such a matrix is called a symmetric matrix. So in a square matrix of order 2 rows 2 column, 3 rows 3 column, 4 rows 4 column, if all the elements above the principal diagonal must be equal to elements below the principal diagonal, then it is called a symmetric matrix. So a matrix A is said to be a symmetric if A dash is equal to A. Now let us consider an example. That is Aij is equal to Aj for all the values of I and j. Now if A is equal to a square matrix of order 3 rows and 3 column, 1 4 5 first row, 1 4 5 second row, 4 2 6, and the third row 5 6 and 7, 5 6 and 3. Now let us transpose this. The transpose of this matrix A dash, first row contains 1 4 5, 1 4 5, second row 4 2 6, 4 2 6, third row becomes third column 5 6 3. See the difference, A and A dash are same, all the elements of A and A dash are same, they are equal. So A dash is equal to A. Such a matrix is called a symmetric matrix. Further here, this is the principal diagonal elements. 1, 2, 3 are the principal diagonal elements. All the elements above the principal diagonal, that is 4, 5, 6 is equal to 4, 5, 6. So this 4 and 4 coincides, 5 and 5 coincides, 6 and 6 coincides. That means all the elements above the principal diagonal must be equal to elements below the principal diagonal. Such a matrix is called a symmetric matrix. That is A dash is equal to A. Now that means all the elements above the principal diagonal must be equal to elements below the principal diagonal. Now let us consider one more example for 2 rows 2 column. A is equal to A 4 5 and 2 5 2. The transpose of this A dash is equal to, so first row 4 5 becomes first column and the second row 5 2 can be written as second column. See here, A and A dash are same. A dash is equal to A 4 5 5 2. So that means here all the elements above the principal diagonal must be equal to elements below the principal diagonal. Let us take one more example. If B is equal to 1 2 2 4, then the transpose of this is B dash is equal to 1 2 2 4. That is A dash is equal to A. That is all the elements above the principal diagonal are equal to below the principal diagonal. So that is A dash is equal to A. This type of matrices, such matrices are called as a symmetric matrices. Now let us come to the next type. Next type is the skew symmetric matrix. Skew symmetric matrix, this is very important. A square matrix Aij is said to be skew symmetric matrix if A dash is equal to minus A. If A dash is equal to minus A, that is Aij is equal to minus of Aij. That means if A dash is equal to minus A, then such a matrix is called the skew symmetric matrix. So here let us consider an example. So 0 4 5 minus 4 0 minus 5 minus 6 0. If you transpose this, what happens? A dash is equal to 0 4 5 minus 4 0 6 and minus 5 minus 6 and minus A dash is, that means here we have positive signs, whereas in transpose we have negative sign. So here we have negative sign, here it is positive. So that means A dash is equal to minus A. If this is multiplied by negative sign, this becomes plus 4, plus 5, minus 4, 0, plus 6, minus 5, minus 6, 0. That is nothing but the matrix A, negative of the matrix. So that means all the elements above the principal diagonal must be equal to elements below the principal diagonal, but opposite in sign, and all the principal diagonal elements are zeros. So in a skew symmetric matrix, all the principal diagonal elements are zeros. All the principal diagonal elements are zeros, and elements above the principal diagonal must be equal to elements below the principal diagonal, but opposite in sign. So that is why A dash is equal to minus A. So it is a square matrix in which all the principal diagonal elements are zeros, and the elements above the principal diagonal must be equal to elements below the principal diagonal, but opposite in sign. Such a matrix is called a skew symmetric matrix, and A dash is equal to minus C. Now let us take one more example. Let me take B is equal to 0, 4, minus 4 and 0. What is this? Here this is transpose of this. B dash is equal to, what we will get? 0, 4, minus 4 and 0. This is nothing but minus B. B dash is equal to minus B. This is an example for a skew symmetric matrix. All the elements in the principal diagonal are 0, and elements above the principal diagonal are same. Elements above and below the principal diagonal are same, but opposite in sign, plus 4 and minus 4. If you transpose this, you will get the negative. B dash is equal to minus B. So if A dash is equal to A, then it is called a symmetric matrix. If A dash is equal to minus A, then it is called a skew symmetric matrix. So in skew symmetric matrix, all the elements in the principal diagonal are zeros, and elements above the principal diagonal must be equal to elements below the principal diagonal, but opposite in sign. That's it. Now let us come to the next skew symmetric matrix. So all the principal diagonal elements are zeros, and elements above the principal diagonal must be equal to elements below the principal diagonal. Let us take one more example. So if B is equal to 0, 3, minus 2, minus 3, 0 and 1, and 2, minus 1 and 0. The transpose of this is, so first row become first column, 0, 3, minus 2, minus 3, 0, 1, and 2, minus 1 and 0. B dash is equal to minus B. This is an example for a skew symmetric matrix. Let us take one more example. C is equal to 0, 2, 3, and this is, let us write minus 2, 0 and 4. This is minus 3, minus 4 and 0. This is, see, all the elements in the principal diagonal are zeros. Further, elements above the principal diagonal is equal to elements below the principal diagonal, but opposite in sign. If we transpose this, what we will get? C dash is equal to first row 0, 2, 3, and second row minus 2, 0 and 4, and third row minus 3, minus 4 and 0. What is this equal to? Minus C it is. So C dash is equal to minus C. Such a matrix is called as a skew symmetric matrix. All the elements in the principal diagonal are 0, and all the elements above the principal diagonal must be equal to elements below the principal diagonal, but opposite in sign is nothing but a skew symmetric matrix. Hope you followed. Now, other hand, let us take the problem. Let us take few problems based on this. Now, suppose if you multiply any matrix with an identity matrix, or if you multiply an identity matrix with any matrix, you will get the same matrix. That is, a matrix A into I or I into A is equal to the same matrix. This is very important property. Now let us come to an example. If A is equal to 1, minus 1, 2, 0, I is equal to 1, 0, 0, 1, and show that A into I is equal to I into A is equal to A. Now let us take first A into I. What is A? 1, minus 1, 2, 3. And 1, 0, 0, 1. This is matrix multiplication. First row, first column. So first row, first column, 1 into 1 is 1, minus 1 into 0 is 0. Same row, second column, 1 into 0, 0, minus 1 into 1 is 1. Again, second row, first column, second column, 1 into 2 is 2, plus 3 into 0 is 0, 2 into 0 is 0, plus 3 into 1 is 3. Add this. 1 minus 0 is 1, 0 minus 1 is minus 1, 2 plus 0 is 2. This is equal to 3. What is this equal to? This is equal to A itself. 1 minus 1, 2, 3. So A into I is equal to A. On the other hand, I into A, if you multiply identity matrix with any matrix, 1 0 0 1 is identity matrix, and the given matrix is 1 minus 1 and 2 3. Multiply this. So what is this equal to? Now on the other hand, let us find out I into A. I into A, that's equal to first row, first column, second column. 1 ones are 1 plus 0 into 2 is 0. 1 into minus 1 is minus 1 plus 0 into 3 is 0. 0 into 1 is 0 plus 1 into 2 is 2. Last row, last column. 1 into 0 is 0 plus 1 into 3 is 3. That is equal to 1, minus 1, 2 and 3. What is this equal to? The same matrix A, 1, minus 1, 2, 3. Now, so what do you say from these two? Let us represent this as equation number 1 and this is equation number 2. What do you say from equation number 2? So, if you multiply any matrix with an identity matrix, or if you multiply identity matrix with any matrix, you will get the same matrix. So, therefore, from 1 and 2, we can say, from 1 and 2, we can say that A into an identity matrix is equal to I into A is equal to the same matrix. A into I is equal to I into A is always equal to A. That is an identity property. Now, let us come to this type of problem. Find X, solve for X. What is given? So, here X minus 5 minus 1, 1 0 2, 0 2 1, 2 0 3 and X 4 1. So, there are 3 matrices. What is the order? This is of order 1 row 3 column. This is of order 3 rows 3 column. This is of order 3 rows 1 column. Just multiply any 2 matrix and whatever the answer you are going to get for that matrix, multiply with another remaining matrix, solve it, you will get either a quadratic equation, linear equation or a cubic equation. Simplify, you will get the value of X. Now, let us multiply these two. These two are equal. Now, we can multiply these two. So, this is first row, first column, second column and third column. That is X into 1 is X, minus 5 into 0 is 0, again minus 1 into 2 is minus 2. First row, first column, same row, second column. So, that is nothing but 1 into 0 is 0, again 5 into 2 is 10, minus 10, minus 1 into 0 is 0. Second, first same, first row, second column. Now, come to the third column, first row, third column, 2 into X is 2X, minus 5 into 1 is minus 5, minus 3 into 1 is minus 3 and this is X 4 1 is equal to 0 as it is. What is this equal to? This is X minus 2 minus 10, 2X minus 8 and the matrix X 4 1 is equal to 0. Now, check what is the order for this. This contains 1 row and 3 column. This contains 3 rows and 1 column. Since these two are equal, you are going to get a matrix of order 1 row 1 column. Multiply it. So, that is X into X minus 2 plus minus 10 into 4 plus 1 into 2X minus 8 is equal to 0. Simplify this. That is X into X is X square minus 2X minus 10 into 4 is 40 plus 2 into X is 2X minus 8 is equal to 0. So, what happens? Plus 2X and minus 2X gets cancelled. What is remaining? That is X square minus 40 minus 8 is minus 48 is equal to 0. Now, this is a quadratic equation. Solve this. That is X square minus 48 is equal to 0. X square is equal to 48. Therefore, X is equal to plus or minus root 48. That's it. So, the value of X is equal to plus or minus root 48. This is how we are going to solve. This is also a very important type problem for 5 marks. Right. Hope you followed. That's it. Just otherwise you can multiply these two and whatever the answer you are going to get for this, multiply with this matrix. Anyway, just multiply any two matrix and the remaining matrix for the answer whatever you are going to get, then simplify, you will get the value of X. That's it. This is how we are going to solve the problem. That's it. Okay. Let's go to the next problem. Now, let us come to the next similar type problem. Let me take a similar type problem. Find X if 1 2 1 1 2 0 2 0 1 1 0 2 0 2. Let us take a similar type problem. So, find X if 1 2 1 matrix. This is of order 1 row 3 column. This is of order 3 rows 3 column. This is of order 3 rows 1 column. So, check just these 2 are equal, we can multiply these two matrices, and the matrix you are going to get is of order 3 into 1. This is same 1 to 1 matrix as it is. Multiply first row, first column, 1 into 0, 0, 2 into 2 is 4, plus 0 into x is 0. Second row, same column. So that is second row here, 0 into 2 is 0, 2 into 0 is 0, plus 1 into x is x. Again, third row, the same column, 1 into 0, 0, 2 into 0 is 0, plus 2 into x is 2x is equal to 0. That is 1, 2, 1. What is this equal to? 4x and 2x. Check the order, see, 3 rows and 1 column. This is 1 row, 3 column. These two are equal. You are going to get a matrix of order 1 into 1. Multiply it. That is 1 into 4 is 4, plus 2 into x is 2x, plus 1 into 2x is 2x is equal to 0. That is 4 plus 4x is equal to 0. Now equate it. So this is 4 plus 4x is equal to 0, or 4x is equal to minus 4, x is equal to minus 4 by 4, x is equal to minus 1. Therefore, x is equal to minus 1 is the value. That's it. This is how we are going to simplify. If it is possible to factorize, factorize it. If you get a linear equation, simplify, you will get the answer. So here x is equal to minus 1. That's it. Hope you followed. This is how we are going to solve these type of problems. Anyway, these type of problems are very important even for 5 markers. Hope you followed. So that's all regarding today's session. Let us meet with the different concept in the next session. Thank you. Thank you very much.